Good morning, good afternoon, or good evening, depending on where you're listening. This is Dan Turchin, host of AI and the Future of Work, advisor at Insight Finder, the system of intelligence for IT operations, and CEO of PeopleRain, the AI platform for IT and HR employee service. Now, we've met authors and investors and journalists over the past few weeks, like Linda Rotenberg, who's building the international entrepreneurial community at Endeavor, and Rishan and Michael from 10X Management, who are helping tech rock stars find gigs. Whenever we talk about the kind of halo surrounding the future of technology, I always gain respect for the entrepreneurs. Call them the angels wearing the halo. Without them, there's no technology and no future of technology to discuss on this podcast. We often describe the kind of archetype engineer turned inventor turned CEO who bootstraps an algorithm into an idea, into a product, into a company. Today, we'll speak with one of those archetypes. Kordel France is a machine learning engineer by training, having received his master's degree in machine learning and AI from Johns Hopkins. He went on to write algorithms for other companies before leaving to start Seekar Technologies in 2018. Seekar is helping commercialize AI-first products in healthcare and other fields like law and professional sports. Kordel and his team were also among the first to use AI to diagnose COVID from radiographic images. For everyone listening, if you don't think you can start a company or that your idea isn't big enough to pursue, listen to Kordel. The future of work is less drudgery and more knowledge work, but only if we use AI to help us rethink what's possible. We need you to step out of your comfort zone. Today, you'll hear one version of exactly how to do that. Without further ado, it's my pleasure to welcome Kordel France and Seekar Technologies to the podcast. Kordel, why don't you start by sharing a little bit about your background and how you got into this space?
Sure. Dan, thank you again for having me on the show. So I actually grew up on a farm, believe it or not. And on the farm, we have a lot of this big machinery, this big equipment. And one day my father brought home some self-steering technology that allowed the tractors to basically steer themselves and get a more accurate application. And I remember first getting in the tractor with him when they first came online and seeing this giant machine that is basically steering itself and acting in autonomous fashion. That kind of solidified my, interest and passion for robotics and artificial intelligence. So leverage that, passion into school, studying computer science, mathematics, and physics throughout my grad and undergraduate studies, and landed a few successful jobs in Department of Defense building autonomous systems, and really at that point became more aware of the lack of understanding, the lack of acceptance in some industries, especially with defense and medicine, but the lack of awareness about the potential of artificial intelligence and how it can be used to solve certain problems. And so that was one of the primary catapulting factors in which my co-founder and I basically started Seekar Technologies upon. And it's we've enjoyed a successful path so far and haven't looked back.
You're one of the rare guests that we have who actually has a degree in AI. Aren't too many of them out there. Talk to us about kind of the arc that AI has been on. Call it, over the last 10 or 10, maybe even 20 years. We talk about an AI summer, an AI winter. Where are we now, and where are we headed for the next decade?
So in my opinion, I think we're in an AI summer. And I think of it this way: artificial intelligence and our development with it has just achieved escape velocity. And now we're in orbit. And so we've made a lot of these small, profound, or not small, but these really concentrated efforts with artificial intelligence in certain realms. And if right now we're trying to determine if we're going to just stay in orbit or if we're actually going to escape orbit and go to these other planets, these other terrestrial objects. And, by analogy, if we're going to actually, implement these into a lot more fields and kind of, achieve that more progress towards that AGI, the artificial general intelligence. But I truly think that right now we are at the cusp of an AI summer.
So, as a society, we're so conflicted about what role AI will play in the future. Is it going to take jobs? Is it going to create jobs? Is it dangerous? Will it improve our quality of life? Fast forward 5, 10 years, give us your perspective on how should kind of the lay citizen think about how AI is going to be infiltrated into the fabric of society.
So first off, I think that artificial intelligence is in the near future, for the next at least 5 and 10 years, going to create jobs because we're going to see a lot more acceptance of artificial intelligence, robotics into a lot more industries and a lot more everyday applications that is going to have to be maintained. So, for example, Seekar does a lot of work in these realms where we try to mitigate safety. So let's take like construction or agriculture, for example, where there's a lot of accidents or a lot of safety features or safety incidences that could be prevented if there were some automated systems in there. And so, you incorporate these autonomous systems and in this AI, and it's able to mitigate these risk factors, but it also needs to be maintained. So you have to essentially maintain the robots, right? And that takes skills. So in my opinion, there could be an effort in which, in the most likely outcome is that these workers that were maybe before exposed to these risks now upgrade their skills to program software or become help diagnose problems with these autonomous systems. And so they essentially upgrade their skills, but it's not really ridding jobs. And that's, in my opinion, the worst case scenario in which a very risk averse job is replaced. But what I primarily think will happen before that is that everyone's throughput and productivity will increase. And so AI will basically allow us to become better at our jobs and become more productive. And we'll just be able to achieve a lot more in a shorter amount of time.
So we often talk about good opportunities for autonomous machines or robots being in roles where humans do tasks that are either dull, dirty, or dangerous. Now, you grew up on a farm. You saw maybe some dull tasks being automated with robotic machines. You agree with that? And how do you think about what are the next set of appropriate tasks for automation?
Yes, I do agree with that, and I think that that is where AI will truly shine at first, is being able to take on these dull and dirty tasks that humans aren't necessarily excited to do, and maybe are a little more they're not quite as safe, and I think that's where it'll first shine primarily because that's where the demand will be. In a similar manner, I think that it will also shine in like, for example, for healthcare, it'll increase again throughput. So physician throughput, enabling them to become more accurate in their diagnoses, but also enabling them to see patients and treat them faster with additional insight that they didn't previously have before.
Now, in this podcast, we talk a lot about the potential benefits of AI on society. And just in the first few minutes of our discussion, you talked about an AI summer, and you talked about net job creation through AI and potentially robotics. One of the things that really inspired me is the work that you and Seekar have done using AI to detect COVID in radiographic images. So no better example of how to apply this technology to make life better, to improve the world. Tell us about kind of the spark of inspiration, and maybe just what did you and your team do to pursue that example using COVID and radiographic images?
Sure. So there's this in your pocket. We've got this mobile device that has the thousands of times more compute power than what we went to the moon in. And what we're using it for now is I mean, most of us use it to surf the web, send emails, social media, things like that. And that really sucks. There's a lot more potential and a lot more capability that's built into these devices that we aren't realizing. So part of Seekar's principles in which we build our products is we want to mobilize AI, make it a lot more mobile so that they don't have to sit on these big computer systems. We want to protect patient or people's privacy. People will become a lot more acceptant of artificial intelligence and robotics if their privacy is protected and they know that we're not trying to monetize their data. The only thing we're monetizing is the product, and we don't want anything else from them. So being able to make these artificial intelligence models live on the device or work at the edge is a primary concern with us, and that's what we try to employ with all of our models, so that we don't have to send data to a cloud server that then has to come back, and in each one of those transactions to the cloud server, there's an opportunity for data manipulation or data exposure. The user's data is protected on their device, and there's less probability of any interference, and we gain more trust from our users that way. Additionally, there's trying to manifest a lot of these potential resources in your phone and your tablets and everything there's a lot that hasn't even been tapped into yet. I mean, we've got gyroscopes and these cameras that get even better over time, magnetometers, all these sensors that we don't really use a whole lot, that Seekar's being able to employ in a lot of his products. So let me give you an example. For neuropsychologists, we partnered with a neuropsychologist firm here in Texas that that was able to basically validate and kind of help in cohesion develop our product. So we approached them and said, hey, we have this technology that we believe can help you do your job better. And here's what it does. It utilizes a tablet and in a clinical setting. So when you come in or when a patient comes in for a diagnostic interview, for example, and they might be wanting to get screened for potentially Alzheimer's or depression or PTSD, ADD, different things like that, our product allows a tablet to capture all this data on a camera. So we're taking footage of the physician and also the patient, and monitoring all of these little different things that are going on with your body. So looking at your pupils, your pupil constriction, how the way in which your eyes are moving around, if they're darting around in a certain fashion, a certain frequency. We do voice analysis on all of your audible speech to see if you're making a cohesive sentence structure. Lie detection to some extent, even to see if you're trying to avoid speaking about a certain topic or avoid speaking about a certain situation. There's a lot of data that can be gathered from all of this, and some of the downside to that, not downside, but some of the argument against that is people don't want to have a camera on them in the physician's room. And that's been addressed by Seekar in the fact that we don't record any of the information. All we're taking in is the data. So it's essentially, we're trying to get all this information to see what's going on in your head, and then allow that to help the physician make better diagnoses based off of what data we capture. For example, when a physician sees, for a physician's day, they might have to see 3 or 4 patients. They're not actually going to go back to your records until maybe a week or so later, and just because of the demand of which they have to address, because they're especially with mental health disorders now, they're in just such high demand from the pandemic. What our product allows them to kind of refresh their memory, get more data and insight onto what happened that day. They have a full transcription of what the physician said, what the patient said, in movie script fashion, essentially, that they can go and recall all of these details from that diagnostic interview. And what it creates is this really beautiful symphony of the physician taking in what the AI advises, and then the physician also critiquing what the AI is doing to make the AI better. And so the physician's capabilities are augmented and the AI's capabilities are sharpened, which in turn just makes both better at their jobs. And it's something that we've validated and we've worked very hard on, and it works. It's totally crazy, but it works. And I truly think that there's a lot of opportunity with that in a clinical setting, in a physician setting, to kind of reap the benefits of AI.
Going back to the COVID app that you developed, the cost of a false negative could be potentially very high. In other words, missing an actual COVID case. talk us through the data challenge behind developing that app. Where did you get your training data, and how do you control for bad data and mitigate the impact of potentially biased data to prevent obviously false positives, but I'm more thinking about the impact of a false negative.
Yes. So that in situations like this, a false negative becomes catastrophic because you're affecting, it's not just a false reading, but it could effectively have consequences on patients' livelihood and many other factors. So our jobs as engineers became much more sobering and much more drastic because we needed to pay extra attention to the data. Where did it come from? How much can we trust this data? And also we went out and accumulated our own. So we partnered with some radiology firms in order to gather our own radiology x-rays from experts. We as engineers don't want to address we shouldn't be the ones signing off on whether or not a radiographic image actually has pneumonia or whether it has COVID. That should be by the experts in the field. So acquiring, trusted data from the experts who have validated it was one. And then also only taking training data from resources like the National Institute of Health, who have also validated a bunch of radiographic images, coupling both of those pools of data together, and then doing further extensive analysis to ensure that random sampling to ensure that actual labels match what the diagnosis really is. There was extensive data preparation and extensive iterations on the data to ensure that we were giving a very holistic and a very non-biased data set to our model, so that it could rule out or garnish the most effective outcomes.
Talked a little bit about putting AI models at the edge on an actual mobile device. A few weeks back, we had a gentleman named Philippe Kaz, who's the CEO of Topio Networks and quite accomplished in the field of IoT and edge computing. And I'll ask you the same question I asked him. When it comes to putting AI models on a device at the edge of the network, say a mobile device, is the biggest impediment to the success of that? Is it bandwidth? Is it storage? Is it processing power? Where you're in the trenches, where are you most challenged when you look to deploy some of these AI models on mobile devices?
Some of the most challenging aspects are both processing power and storage. So processing power is, actually becoming quite good enough on mobile devices to run these artificial intelligence models, and storage is also following suit. But it wasn't until recently that they actually became appealing. Even still, a person that wants to download an app with an artificial intelligence model doesn't want to use their entire hard drive to store the artificial intelligence model in this app. So trying to compress these models down into a size that is reasonable for users to be able to use, but also doesn't lose any accuracy, any sensitivity, any specificity. That's kind of where the real grit comes in, and where a lot of the hard engineering really addresses those problems. Additionally, since we don't rely on an internet connection to make our artificial intelligence predictions, there becomes a problem in which, how do you verify that the model is actually performing it the way it should? You can't acquire metrics because we're not getting these results back. So building these self-monitoring algorithms into the artificial intelligence algorithm to basically self-diagnose its sensitivity and specificity. And when it gets below a certain threshold or misclassifications, it says, all right, basically I need to update, or I need to perform some other I need to do something different because I'm not giving the user the accuracy that they deserve. That, in my opinion, is another problem at the edge, because the world is dynamic, and when we deploy a model at the edge, that it might work for a very specific amount of use cases or specific amount of time, but it doesn't. It begins to lose accuracy as soon as the data, the testing data, or evaluation data, transitions in a slightly different manner, and it's got to be retrained again. So that's a pretty interesting problem that Seekar at least is addressing in its products.
This show, we've talked about how the impact of biased data can seep into AI models in very innocuous ways. I've given the example of at PeopleRain, in very subtle ways, we're making recommendations about, let's say, which contractor should be used to fix a trouble ticket in a retail restaurant, for example. Doesn't seem like a data problem that would be particularly vulnerable to bias in the data. But if the model starts to select, let's say, large global systems integrators versus, local minority-owned businesses, it could potentially perpetuate that decision-making process and lead to, very unintentional bias in, against minority-owned businesses through no fault of the algorithm developer. And yet, me on a soapbox, but I maintain that it's our role as model builders, as AI developers, to introspect the data for potential inclusion of bias. Talk to us about your responsibility as an algorithm developer, and what do you do to control for biased data?
So there was a gentleman on your podcast a few months ago, Derek Van Brunt, if I remember correctly, and he spoke about this really eloquently, and he made a point that there's a lot of resources online on which you can build some models or an artificial intelligence model in maybe 10 lines of code and feed it a bunch of data, and they output these results and they work. And what I fear is that there's a lot of this to some degree going on in some of these actual deployed artificial intelligence models, where the data, these tutorials or these guides online are meant to be more of educational, but they don't really say a lot about what's going on under the hood. They don't allow the engineer to really understand the math behind it or why an artificial intelligence model made a certain diagnosis. And another reason along that thread is that a lot of the training data might not really have been gone through when it's actually used to train a model. So we might say, okay, well, I'll take this as gospel truth that the labelers actually, labeled this training data correctly, and there was, they had appropriate quality control standards going on. And there needs to be another level on top of that. So you need to ensure that if you download a data set online, that there is probably your own quality control procedures followed in order to ensure that the data actually says and does what it's claimed to do. And so these two problems coupled together, I think, allow and contribute to a lot of bias within the data. And again, it's no fault of the algorithm developer. One thing that we do with Seekar is we try to constantly update these models as much as possible while maintaining people's privacy. So being able to go through and say that, okay, we're seeing, an unbiased amount of occurrences in this regard of identifications for red cars. Why is that? Is it really identifying a lot of red cars, or is, there perhaps some bias in the model? Making sure that you have, for example, if you're identifying all the different colors of cars in the parking lot, you have an appropriate or an equal amount of training data for blue cars, for red cars, for green cars, for yellow cars. And it's not going to inherently bias what's going on in the training process, while also understanding exactly what's going on with your algorithm. I think that's key, or at least one key in addressing bias. If you can one thing we make all of our engineers do is fundamentally explain what's going on in the algorithm, both technically and to a non-technical person. Because if you can't explain what's going on and you don't know what's going on, it doesn't end well. So we've got to be able to explain what's happening. Part of artificial intelligence or the connotation around it is that a lot of it is a black box. So you put a bunch of data in, you get it out, and you get a result out that's most of the time right, or supposedly right. But we're trying to eliminate that. So by making it not so much of a black box in order to get these results. So in our products, we implement some explainability into these models that give the user, a more sense of security for one, and also help eliminate bias, because we're able to deduce exactly where that bias is and what part of the algorithm it's biased in. So in a neural network, if it misclassifies an object, we're able to find out, where in the algorithm, what mathematical operations or series of operations contributed to that bias, and address it accordingly, so that we're not giving these black boxes to our customers that we don't know anything about. We build all of our AI from scratch, which I think if companies employed that, it would be a huge contributor to reading bias.
So if a customer of a Seekar product questions the integrity of the data or asks to explain a result, do you have automated features that provide explainability, or how do you address that concern?
Yes. So we have a quality control procedure that, with the customer's permission, we can go in and initialize on the exact model on their device to say, okay, so we're going to actually pull data from this device. Do we have your permission, essentially, so that we're not violating your data? But we want to see what's going on and address these, possibly true allegations that the model is misperforming. And so it's this quality control operation that goes in and gets this giant log, this giant report, if you will, that it displays exactly how the algorithm arrived to its classification and arrived to its resolution. This was of critical importance, especially starting out with that radiographic image classifier, but also with all the stuff we're doing in neuroscience and medicine, because we've got to be able to explain our results just as a physician can. If we can't explain our results, or the AI can't, we're not going to garner trust, and we're not going to we're not going to have people leverage AI in these realms. So it's become very important, and these reports people actually really appreciate and take to heart once we can go in and explain, hey, we were wrong, and we'll go through and address this. The model was right, and here's why we think it was right, kind of a thing.
So I will tell you, you and Seekar are in the minority when it comes to taking responsibility for the explainability of automated decisions. Mm-hmm. I foresee a time in the not too distant future when all AI will be judged kind of like restaurants get a hygiene scorecard. There'll be an equivalent kind of scorecard for AI kind of model, quote, hygiene. In your estimation, would that become a tax on innovation, or is that something that should be enforced to regulate the explainability or the quality of automated decisions?
I do think it should be. I do think it should be enforced eventually. Right now, part of the beauty with artificial intelligence is that we're able to make such rapid leaps in progress, and we're able to move the needle so far in such a short amount of time, because there's no red tape. There isn't any regulation. I can build an AI model. You can build an AI model. Anyone can build an AI model, essentially, and deploy it in a product. But there is some speculation that maybe there does need to be some regulatory agency that acts as an FDA, as an FAA, to say, hey, you guys are using artificial intelligence in an appropriate manner. Your data is clean. We validated it based off of what you've given us, and you've gone through the appropriate approval steps to release your product. I think that will become mandatory in the future, primarily for the realm of particularly medicine and defense, or any of these safety critical applications, because if you're trying to identify whether or not a misclassification online for Amazon and shopping is a lot different than a misclassification on whether or not someone has COVID-19 or whether or not someone has a life-threatening disease. And so particularly in these very sensitive applications, when the misclassification is very, very bad, I think that there need to be an authority or regulatory agency that can address the models and the data to ensure that they are of quality.
Kordel, this has gone by quickly, but we're about out of time. But I can't let you go without asking one last question. So I mentioned at the top of the show, so you're a student of AI. So you've got a master's degree from Johns Hopkins in AI and machine learning. You got a lot of listeners who are thinking about maybe formalizing their education in AI and machine learning. What's your advice to them? Where's the field headed, and anything that you've learned through your formal introduction to the field?
Artificial intelligence is a new field. It's still in its infancy. There's been a lot that's happened in the last few years, but it's still, in my opinion, we're still trying to break out of that orbit, right? And it requires a different level of thinking. So I think it's important for students to not to leverage the current the past and the present to influence the future, but you've got to break the status quo and question how things are done in order to really capitalize and utilize the potential of artificial intelligence. It's so new and there's nothing that's really been like it in the past that it's important for us to kind of shift the way we think. So don't be afraid to basically rethink anything that's already been done or any principles that we follow today. Additionally, I would encourage anyone to just get into coding. There's a lot of resources online in which you can build a plethora of projects in a short amount of time over the weekend. And whether you're building arts and crafts or you're wanting to build something for car mechanics or whatever that might be, there's several applications out there that I think anyone would reap the benefits and really appreciate software development. Um, on addition to that, they'll also gain an understanding, further appreciation of what's going on in artificial intelligence and kind of how to address some of these problems we just spoke about.
So you were inspired to code watching autonomous vehicles on a farm.
Yeah,
What was
believe it or not.
how did your coding career start?
So I started in high school writing code, and I was actually trying to automate a lot of my calculus homework. So trying to make it do differential equations and all these different things. And my father wouldn't let me, but I wanted to try to program some of the self steering software on our agricultural equipment. But I don't know, I don't blame him in hindsight, but he didn't want me to mess it up, so I didn't. I didn't end up doing that. But I looked heavily into coding my own autonomous systems and writing software for that in high school, and it's changed a lot since then. There's a lot more resources online. Thank goodness.
Well, there you have it. That's good advice. Learn to code so that you can get better grades in calculus.
Yeah,
That's the takeaway. Good stuff, Kordel. Well, we're out of time, but as some of these trends that we've talked about come to fruition, maybe we'll have you back and see how we did with some of these prognostications. How's that sound?
that'd be great. And thank you
Good.
again to you and to all your listeners.
Good. Well, such a pleasure having this conversation. Best of luck to you and Seekar. Thanks again to Kordel. Great discussion. We are back next week with another fascinating guest.